The overall goal of this procedure is to test microelectromechanical structures to be used in static and dynamic applications using optical full-field measurements with computational and experimental techniques.
This method can help answer key questions in the semiconductor industry and more specifically for microelectromechanical system inspection, such as the characterization of the mechanical properties of MEMS structures at different stages of manufacturing. The main advantage of this technique is that it is full-field, non-contact, real-time, high resolution, and it provides a fully quantitative 3D map of the reflective object. The system have been made with no lens and hence is really compact.
Though this method can provide insight into MEMS characterization, it can also be used for wafer inspection or optics roughness testing. If set up in a transparent geometry, it is also possible to inspect micro-optics, diffractive optics, or even used for bioimaging.
This procedure uses a compact digital holographic microscope, or CDHM, to characterize a microelectromechanical system or MEMS device. For this demonstration, an 11 square millimeters silicon wafer with square gold electrodes positioned every 0.25 millimeters will be characterized. Using tweezers, place the MEMS sample on the sample holder. Adjust the sample holder so that the laser beam targets the electrodes. The largest possible field of view is limited by the camera sensor, and in this case is 2.3 by 1.8 millimeters. Vertically position the system about 1.5 centimeters from the sample and proceed with setting up the 3D view software.